Hello everybody and welcome back to the Code Wrinkles channel for a new video that I hope you will enjoy very much. You may note that the Microsoft Build conference for 2020 just wrapped up a few days ago, and one of the major announcements that was made there is actually that Blazor WebAssembly is not a preview product anymore. So yes, you heard it right. This means that if you install the latest .NET Core 3.1 SDKs, you will be able to just get started with Blazor WebAssembly right away. No need for preview versions or anything else. Blazor WebAssembly is now a full-fledged product, part of the .NET Core family, and you can build your applications with it. So this is why I think that it might be useful for those of you who might be newer to Blazor to just go through the getting started part to see exactly how we can spin up a new Blazor WebAssembly application, how this type of application really works, how our C# files, our DLLs are shipped to the browser, and then of course go a little bit through the project to understand exactly how this type of application is set up. Because this would be really a good building block or a foundation to be able to build upon it and then create maybe our real Blazor applications. So let's get started with this. I'm right now here already in Visual Studio and I will create a new project, I guess, and I will choose Blazor app. So if you search here for Blazor, if you have installed your latest packages, you should find it. And if you click next, of course we have to give a name. Let's call it Hello Blazor, this application, right? That should be a good name, I guess, for the start. And just let's create the application. Of course that I have a problem because the project already exists. Hello Blazor WebAssembly in that case, and I would say that this should work. I'm fairly sure that this name doesn't exist. I haven't created any Blazor application that should have this name. And right now basically we have to make a choice. We have here two different type of applications that we could actually build. First, we have here this Blazor server app, which is the part of Blazor with the server-side hosting model that is already part of the .NET Core since the release of .NET Core 3.1. But then we have this Blazor WebAssembly app, and this is new because this is the real Blazor WebAssembly project that would basically ship your DLLs to the browser, and the entire application will basically run in your browser through WebAssembly. So of course we will check this right now here, and we won't choose here this authentication. For now we don't want to do that, and then we just go create, and that would create our first Blazor WebAssembly project. So just to make a short recap, if you're not that familiar to Blazor, Blazor is basically a single page application framework, but you write your applications in C#. So we can make an analogy and say that Blazor is kind of like Angular or React or Vue, only that you write your code in C# and there is actually no real need to have JavaScript in there. So this means that also your users will get the full single page application experience with no reloads of the page or of the application and so on. So if we run this application right now, because it's a template that's fully functional, we can just go on IS Express because we still need a web server that would serve this type of application. So this is why when we debug, it runs in or on top on IS Express. But it will open a browser, and if I go here on F12 to see the developer tools, and if we go to network, we should see here a lot of DLLs. And you can notice, or we can see that we have all the DLLs basically that are referenced right now in our application were loaded in the browser right now. So of course when you load it the first time, all these type of DLLs need to be loaded, and the download size will be a little bit larger than what you would expect. But browsers do cache this type of file. So basically if we clear this and if we refresh it, we will see that right now, as you can see, all the other files were already there, so they weren't fetched from the server because they are cached by the browser, and now the download sizes are really smaller. So this is one thing that you should need to be aware of, that right the first time when you load the application or when the browser requests that application, download sizes might be a little bit bigger, and also it depends on the number of packages that you have to ship to the browser. I guess we can close right now these developer tools, and this is a very basic Hello World application. From the Blazor template we have here a few components, just a counter on which we can click, and of course it increases the count and the current count. And we also have this fetch data component that actually makes a call, an HTTP call to a service. However, we'll see just in a while that it actually doesn't make a real HTTP call, but it kind of simulates it just to show us how HTTP calls should be done. But the idea is that it gets it asynchronously, and we will look into that type of code just in a few seconds. Now, of course, the only problem is if we click back to this counter, it's set once again to 0 because we don't have anything like state management here in this Blazor application right now. But that's surely something that we will look into the future. So we'll probably try to build state in our Blazor application in a later video. But for now, I guess we can simply close the application because we don't really need it anymore. Instead, I just want to go through the project structure and to understand the files that we have here and what are the roles of each file, I would say. And the first thing that might struck you is that we don't actually have a startup.cs class. And that's actually not really a problem, because in startup.cs, even in ASP.NET Core, we basically do two very important things. First of all, we build our middleware pipeline, so we can register our own middleware or a middleware that is built in ASP.NET Core. And the second important thing that we do in the startup class is we register services. Now, of course, if we think that this application will basically run in the browser, we don't have something like middleware here because we don't actually work with real requests, because everything is like an application that really runs on your browser. So we don't really need middleware. So in that case, we don't have here a startup class, but we still need services, of course. However, services can be, of course, registered here in the program.cs class, which is the entry point in the application. And also in normal or regular ASP.NET Core applications, the program.cs class is actually the entry point in your application. So if we look through this code here and we try to understand what really happens, is really nothing very complicated. We simply build a host for our application to run. So in the case of ASP.NET Core application, it would be probably a web host, but we can also use generic hosts so that our ASP.NET Core applications run, for instance, in consoles or somewhere else. So being this Blazor, and since Blazor is built on top of WebAssembly, or well, we need WebAssembly to really run Blazor in the browser, we have here a WebAssembly host builder, and we create it with the default arguments. And we also then register the root component for this Blazor application. So this is the second step. And finally, or the third step here, is the services registration. And here we see that we already have an HTTP client registered. And if we click on it, we see that well, it initializes a new instance of HTTP client class using HTTP client handler. So yeah, basically this means that our Blazor application already will have an HTTP client inside of it, so we will be able to inject it and use it throughout our Blazor components. And just in a few minutes we'll also look how this HTTP client is actually really used in a component on this template. The idea is that here there is one thing that we have to take into consideration when it comes to Blazor. Once again, here we are running everything in the browser, so we don't have any real requests. What this means is that basically when we add services, all services that we add, if we add them as transient and maybe even scoped, they actually will behave as singleton services in a regular ASP.NET Core applications. Because once again, we don't have requests here. Everything runs natively in the browser. So that's why in this case, when we add this service, we can add it as a transient, and it will create a new HTTP client. and it will use as a base address the host environment base address, which kind of makes sense, because purely theoretically what we would normally have, I would guess, when we really want to build apps for production, we'll mostly have an ASP.NET Core backend with a Blazor frontend. It's really a similar model to what we had with Angular, because actually one of my most popular videos here on YouTube is called building an ASP.NET Core backend and an Angular frontend. So this type of tools that we use to build our full stack application change a little bit right now, because we don't have Angular. We still have the ASP.NET Core backend, meaning we don't have it here right now, but we could add it, and we have the Blazor frontend acting actually like a regular single page application. And then of course we build the builder, and then we run it. So this is what the program class does. Of course, if we want to add our own services, and this might be of course a real scenario, so in our Blazor applications we will most probably have to add our own services to it, we can simply come back here and use this builder, the services on the builder, which is a regular iService collection. So it's exactly the same thing that we get in ASP.NET Core in configure services. And then we can simply add all our services that we need, and those services can then be injected in all the components and all the code and the classes that we need in our application. So let's go to the next file, and that would be the app.razor. And as said, this is kind of like the entry point in this application, and we see here that basically we implement, or the router component is basically added here, and we have two scenarios. If we found the route, then we get the router data or the route data in the context for that route, and about routes and how we use route data and so on. I'm sure that I will do some other videos where we will talk in depth about how routing works in Blazor. But right now it's the whole idea that if the router data, we specify the layout that we want, and we will look into the layout just in a few minutes, and then basically our application will display our component. But if the route is not found or not activated, or we have errors, whatever, in this case we still use the exact same layout, but we will display this message that sorry, there's nothing at this address. So this is kind of like a 404 not found. But in case of Blazor, we cannot really display 404 not found, because we actually, this is not the result of an HTTP call. So this is this app.razor file, which is a regular component, but that is defined and that serves as the entry point, or let's say the top component in all the component hierarchy. And then if we go one file above, we can see this imports.razor, and here is actually the place where we can import or use these using statements to import all the libraries that we actually need for this application. And in fact, if we go here to dependencies, and if we go to packages, we see that we have some packages installed, and parts of that packages are referenced here with this using statement. So this is how we basically make different packages available to our Blazor application. So this is a very, very important part. So basically each time that you want to add a new dependency, maybe your own class library, or maybe a third-party NuGet package, whatever, then you would have to come back here and also add a using statement, so that the Blazor application knows about what should be present in the application and not. So let's go then up one folder, and we see this shared folder. Now I'm sure I'll make a new video about how we should structure our Blazor application, because this is actually a topic that I have investigated for a fairly long period of time, and I mean I also gave some conference talks about this topic. But commonly also as a pattern that we use in Angular or React, we usually have a shared folder or a common folder where we basically place components that we reuse throughout our application. And this type of shared components or common components are usually not routed components. They are components, I don't know, like buttons, maybe not like layouts, things like that we simply reuse just to display something, but not to route to them. And here we have 3 different files. Let's start with the topmost one. So first we have this main layout razor. This is a regular component that, however, inherits this layout component base. And each component that inherits this layout component base basically becomes a layout for the Blazor application. So this means that we could theoretically create our own component, and we can inherit it, or we make it inherit from a layout component base. And what this means is that, for instance, in this app.razor, when we specify here the default layout, we can simply provide our own layout and not this layout that comes shipped here with this template of a Blazor WebAssembly application. So this is also a very, very important part. Now, for what we have here, it's a very simple Razor syntax where we have basically the sidebar, and here we have the nav menu, which is another component that we will look just in a second. Then we have another div, and we have here a bunch of other divs that display some things. Here it would be like a survey, and then here it would be the body. And the important thing about layouts is that layouts in Blazor are actually the only components that can basically say, okay, here comes a body. And when we say body, basically that would be the place where we would place, or where our components will be showed. Then we have this nav menu component, which is actually put here in this div that has the class sidebar. So it's probably the sidebar on the left that we saw earlier. And if we go to nav menu, we see that this is another component that has some basic information here. And for each item, for each button, it has this nav link. And if we put our mouse, if we hover our mouse on nav link, we see that this is basically a component that renders an anchor tag, automatically toggling if it is active or not. So this is basically a built-in component in Blazor that we can use, and it's suitable for nav menus. And this is why this type of component navlink is used right here, just to provide basically navigation to other components like the counter, or like that fetch weather data forecast. So that's pretty it for this part of Razor syntax. But what we see here is that we have this code directive, and here this code actually means that here is the place where we can put our C# code. Because once again, the main idea behind Blazor is that you can build basically a single page application using C#. So this means that in your component you have basically 2 parts. You have first of all the markup, but then you have the logic that implements basically the entire business logic for that specific component. And this is exactly the same like we have in Angular, for instance, because there we have, of course, the HTML file, but then we have also the TS file, the TypeScript file, where we basically put in the logic for that specific component. So it's exactly the same here, only that here, at least in this case, we don't have 2 different files. We put everything in the same file using this code directive, and simply then writing down our code. Now I will surely make a different video about how we should structure or architect our components, because in my opinion I think that placing the logic or the C# part and the markup in the same file is not really the best idea, because also markups tend to become fairly large, and to also add additional C# code at the end of markups, it's not really a very good thing to do. So we can basically split this type of components in 2 different files. just like we have in Angular. So we would have then a file that contains only markup, and we will have then a file that contains only the code behind, or the logic for the specific component. But as said, I won't dwell on this right now, but I promise you there will be very soon a video here on this YouTube channel that will talk in depth about components in Blazor and how we can architect like real components that also respect most of the solid principles, and not just put everything together in one file, because that really doesn't help a lot. And then we have another component, which is this survey prompt that basically displays a link to a survey that we can take, and that's mostly it. Now what we can do here is use different properties in this component as parameters to pass data from a parent component to a child component, and we'll come back to this just in a second, and we'll see how this is supposed to work by implementing our own parameters on a component, because this is something very easy, and I guess that it is a very important part also maybe to learn from a very basic getting started video. Now in this pages folder, what we have are actually the components, the routable or the routed components that make up our Blazor application. So we have this counter component. As we see here, we have the basic markup for it. We see that it has this directive page, and it provides an endpoint, a URL, let's say. And this means that each time we make a request for, I don't know, localhost, so that the host name then /counter, then the application will route to this component and the counter will be displayed. And then this counter just has a title and a button, and the button has this onClick event just like in JavaScript, only that in this case, in this onClick event, we just say, please then run this increment count method that is defined in the code part, so in C#. And here we don't do anything we don't do anything fancy. We just increase the count of this counter, which is a fairly easy thing to do. But here we already learned that we can basically hook up into browser events and then execute methods or logic that we define or that we write in C# in our code part of each component. Now the fetch data component is just a little bit more complex, because it also injects the HTTP client. And remember, we registered the HTTP client in this program class as a transient service. So it's exactly like in ASP.NET Core. The services that you register here are registered in a dependency injection container, meaning that you can simply inject them wherever you need them. So in this case, in this fetch data component, we can just use this inject directive and inject the HTTP client that is added to this to the dependency injection system here in Blazor. So right now, of course, there is an if-else logic here implemented in Razor. So if forecasts equals null, so if we don't have any forecasts, we just show a message that says loading. But otherwise, we just go ahead and render or define a table in our component, and using, of course, Razor syntax, we can go for each and iterate through the collection of weather forecasts. And for each weather forecasts, we just display the information. You can see here that we can also do toString methods or other extensions methods. We can implement our own formatters and so on. But I'm sure that we will cover this in further Blazor videos here on this Code Wrinkles YouTube channel. So this is very important. If you didn't subscribe already, please hit the subscribe button to stay up to date and to get in touch with all the new content around Blazor that will be uploaded here on this YouTube channel in the coming days, weeks, and probably months. That's not something that is gonna end very easily. So let's go further, and now going to the code part of this component. It's something very easy. We just see that we have a weather forecast array. The weather forecast is defined as a class here that has a few properties, a bunch of properties, so nothing very fancy. The only thing that we can see here, or the only more exciting thing that we see here and that we didn't see so far, is that we override this onInitialized async method. similar to Angular components, also components in Blazor also have lifecycle events, and these are events that are triggered at different stages of the life cycle of a certain component, and we can just simply override them and bring our own logic into this type of events. So what we do actually here is say that basically when this component is initialized and it is built by the renderer tree, then just use the this HTTP client, get the data of type weather forecast, and this is actually basically Blazor, or the HTTP client in Blazor is working with some extension methods that were prepared, I would say, especially for Blazor. So this you won't find this exact method on a regular HTTP client. But the good thing here is that we can just read data from sources like an API, and then we can just say, okay, please map the data that we receive, basically the JSON that we receive, to a certain type that we define in our application. In this case, it is a weather forecast. And the idea is that in this case, what happens is actually that the HTTP request is actually faked, because we don't really make an HTTP request, but we simply read a file that is specified here in sample data, and we see here we have this weather.json. So in this case, the HTTP client doesn't really make an HTTP call, but it simulates an HTTP call by actually reading the data that is provided basically in this sample data directory in the weather.json file. So this is how an HTTP call would theoretically work. So in this case, instead of simply reading the data from this file, we could really make a call to a certain API and get the data that we need. That data would be then serialized to the object that we actually want, and we can use this object in the Razor part, as we see here, just basically to bind the information that we have there in HTML tags actually. So this is how this component works. Now, of course, in the www root folder, we have some default files, like, okay, we have static files like CSS files, and there is some bootstrap here, there is some open ionic, there is also an app.css. So these are all CSS files that come shipped with this template. We have also an icon for our application, and we have this index.html page. And in this index.html page, you see that we basically have the head of the page. So if you want to add meta tags, whatever you want to do, you can add it here. So you have to come here to this index.html page and add whatever you need to do here. There's also some scripts added, and here it's very, very important, this script that is added just before the closing body tag. And it says, we see that it's in the framework, and it's basically Blazor WebAssembly.js, and this is a JavaScript file that allows us to work with the WebAssembly inside the browser, and is really needed in order for this Blazor web app or Blazor WebAssembly application to work. So right now, if we run the application, it's of course we get exactly the same result. But I also want to do some very, very, very basic code here, and just to give you a feeling about how things can be done in Blazor, because I can promise you, as said, that there will be more videos about Blazor where we will go in depth in a lot of different topics. And here, if we go to this pages folder, we have this counter component. And right now we see that for this counter component, we have here an h1 tag that simply says counter. So it's basically a strongly typed title, and we want this. We don't want to make this strongly typed. So let's go here to the code part, and let's add a property that let's make it public. It would be of type string. It would be a title and get set. Now, if we want in this component, we can set a default value, and we say here it's default counter. And we'll see just in a second why I wanted to do that. And in this case, in the markup we just can replace the strongly typed title with the title property that we define in our code. So in our, let's say, C# part. Of course, here we also need a semicolon at the end, but now everything should be fine. So right now, if we run this application and navigate to the counter, we should see a different title, which would be the default counter. This is the title that we set here basically as the default. So let's run the application once again. It loads all the DLLs in the browser right now, so it's loading. And if we go on counter, we see here that we have this default counter. Now let's close this and let's actually see how we can basically reuse this counter component in other components. And in that case, we can also pass data to this counter component. So what we want to do right now, right, is to actually come here and here just before the table, so just before the table with data forecasts, I say that I want to place the counter. So I can totally do that. And if I run the application right now, let me run it. So it's that easy to add a component to be displayed in another component. And in this case, what we have is actually a parent-child relationship, and that's very important. And we see that also here we have now this counter, and if we click it, of course, it increases the count. If we go to this counter, we still have this counter here. However, a neat thing that we could do here, and this is the most complicated part in this video, is that what we can do is when we have this type of relationships, parent-child. So in this case, we have this fetch data component, which is the parent, because the fetch data component is the one that says, hey, display me the counter here. So the counter becomes a child component right now. So when we have components in Blazor that are, or that find themselves in this kind of parent-child relationship, we actually have a way to pass data from the parent to the child. And in that case, we can do this using the parameter attribute. So if we go back to the counter, the only thing that we would need to do is just to decorate this property with this parameter attribute. But I also have to type it correctly, of course. Typos don't count. Okay. So right now, this becomes a parameter for the component, and parent components can simply pass data to it by using the name of the property. So if we go back to fetch data, what we can do right now is right here, we can say title, and we can see that we have also full IntelliSense support on it. It displays us this property. And I would say here, this is the weather forecast counter, and that's basically it. Now if you run the application, what we should see is actually that our two counters have actually two different titles. And let's just wait a little bit, and here we have this counter which still has this title of default counter, correct? I assume it is, so it is expected. This is what I would expect. But then if we go to fetch data, we see that even if we still have, so it's the same component that we display here, but in this case we simply pass in the title of the component from the parent to the child, and then of course the component displays the title that we passed in. So in this case here, if we click on counter, then the title of this component is default counter, but if we click on fetch data, then the title of this component is what we have passed in, and it is weather forecast counter. And of course it still works. When we click the button, it just increases the counter. Of course, if we navigate away from components, as said, there is no built-in state management system right now, but we'll also look in other videos how we can bring state, or how can we manage state in our Blazor applications, maybe using a service that we could deploy and register in our Blazor application, but maybe also in conjunction with other very browser specific features, I would say, like for instance working with the local storage or working with the session storage and so on. So I guess that should be it for the getting started with the bare bone, the really blank Blazor single page application without any backend, without anything. We have an application that is actually running C# in the browser, which is cool, I say. And of course, this is a very simple template, but I just wanted to really go through all the building blocks of this very simple Blazor application, because as said, this could be the foundation for everything that we want to do from right now on Blazor. And I promise you there will be some more videos about Blazor, about components, communication techniques, patterns that we can use for components. Then how can we bring state, how can we add authentication, how can we add logging, how can we make real HTTP calls. So all these are really topics that I want to cover in forthcoming videos. So once again, if you didn't do this already, please subscribe to this channel to just stay up to date. There is also a lot of other great stuff coming here on the channel, like videos about how to build a DDD application, so an application using domain-driven design principles, how we build an API from scratch targeted for beginners. There are a lot of other, I would say, fairly instructional videos about algorithms, about C# from zero for those of you, or if you know anybody that wants to learn programming from scratch. This channel, I guess, is a good way to start, and of course it's totally free, so you don't really have to pay anything for it. So yeah, this being said, once again, please subscribe, like this video if you found this information useful, and I promise you that in the real future there will be some more videos on Blazor. Thank you very much for watching, and have a nice day.